PD controller, check it out. If you use PD controller in a second order system, it will increase the damping ratio. Yes, it will increase it. This is the derivation what I given. If I give the direct statement, is meaningless. If you use the PD controller in a standard second order system, it will increase the damping ratio. Yes. Omega n for the system remains unchanged. Yes. Just now you saw. Check it out. This is the omega n. It is the omega n. There won't be any change in natural frequency. Yes. Omega n remains unchanged. Yes. It is also given explanation. It is also given. Type of a system remains unchanged. Yes. Type of a system remains unchanged. It is a type 1. It is also type 1 system. PD control will not change. Type number. Then it will reduce the peak overshoot. Peak overshoot means MP. MP equal to e power minus zeta pi divided by square root of 1 minus zeta square. MP is a function of only zeta. If zeta is increasing, MP is going to decrease. Peak overshoot. This is, if it is step input, assume this gap is there now. That gap is called MP. MP, this gap. If zeta value is increasing, number of oscillations is going to decrease. Then it is also coming down below the input. So peak overshoot is going to decrease. Check the different value. If you take without zeta, without controller, assume zeta equal to 0.5. Without controller, assume zeta equal to 0.5. Then find the MP value. Find MP for zeta equal to 0.5. That means zeta is a 0.5. So then find the MP value. How much MP value you can check it out. For zeta is increasing means assume zeta equal to 1. Assume zeta plus something. Check it out. Zeta is increasing. Zeta 0.5 plus something. Assume this for something is 0.5. 0.5 plus 0.5 1. Now find MP. Find MP value. Compared to this one, compared to first one, MP is going to decrease. This zeta equal to 1 is with controller. With controller. So that is advantage. So if zeta is increasing, then steady state response will not change, but transient response is going to improve. Improvement, number of oscillations are decreasing. If number of oscillations are decreasing, we can take the reading without error. Next, it's a settling time decreasing. Yes, settling time TS equal to 4 by 2 zeta omega n for 2% tolerance band. I explained this topic in a time response. Zeta increasing, time response, settling time decreasing. Steady state error remains unchanged. Yes, I give an explanation. Steady state error remains unchanged. Overall, it will improve the transient part of a system without affecting the steady state part. That is the PD controller. PD controller, if I give single statement without giving all this derivation, okay, Michael, now done. PD controller will improve the steady state response, transient response without affecting the steady state response means this is meaningless. This all are the derivation. The way I given this derivation part means to explain all these steps, I use 2 slides. These 2 slides to explain all these points. In the same way, you can see the PI controller. PI controller with and without. You can bear with me. I will take extra time also. Without a PI controller. Without PI controller, I will draw the approximate diagram because our time is running out. Without controller. This is omega n square divided by s into s plus 2 zeta omega n. Then it is a C of s. Same diagram. Same diagram, you can take it out. It is a negative feedback. It is R of s. Then it's a G of s, H of s. That means open loop transfer function is omega n square divided by s into s plus 2 zeta omega n. Then it's type number, type equal to 1. Then Kp, already given the derivation part. Check it out. I'm taking without control means you can take all the left side derivation, all the left side derivation you can take. This is without controller. I given the derivation part, I'm taking the direct value here. Kp equal to infinity, then I got ESS equal to 0. Then Kv is equal to, how much I got? Omega n divided by 2 zeta. Then ESS equal to 2 zeta A divided by omega n. There is some error is there. Then closed loop transfer function. I given derivation part in the previous slide. S square 2 zeta omega n s plus omega n square. So order is 2. Order is 2. The remaining zeta is there. Now I'm going to take the with PI controller. With PI controller. P means proportional, I means integral. Output of PI controller is proportional to error signal, integral of error signal. Check it out. I'm giving the theory part about PI controller. Yes. This is PI controller. This is actually a KP. The definition. PI controller will produce the output signal consisting of two parts. One is proportional to error signal and other is proportional to integral of the error signal. To remove that proportional to error, to remove that proportional symbol, I'm using KP because U of t is directly proportional to E of t, directly proportional to E of t plus integral of E of t dt. To remove this proportional constant, U of t equal to Kp into E of t plus Ki integral E of t. Then apply Laplace transform, you will get U of s equal to Kp E of s plus Ki. Apply Laplace integral, Laplace of integral is 1 by s E of s. Laplace transform of integral x of t dt is x of s divided by s. Okay, and then output by input Kp plus Ki by s. So this is the transfer function. This is the transfer function. We'll put it within a block Kp plus Ki by s. Check it out. Kp plus Ki by s. Both are adding forward path, forward direction. So same thing, I'm going to use it here. Use a different color. Yes, this is the summing point. It is a PI controller transfer function. Kp plus Ki divided by s. Then standard second order system is omega n square divided by s into s plus 2 zeta omega n. This is a C of s. Then unity feedback system. I'm taking unity negative R of s. So first I'm going to find a open loop transfer function. Open loop transfer function equal to just multiplication of these two. Kp plus Ki divided by s into omega n square divided by, please you can bear with me, extra 10 minutes. Today I will take extra. In the next class I will compensate that hour. If you take LCM here, LCM, this is s Kp plus Ki divided by s omega n square. Already s is there. Now it becomes s square, s plus 2 zeta omega n. Now can you check it? What is the type number? Type number will become 2. Previous it is a 1, it become type number 2. Because of PI controller. Yes, PI controller will increase the or change the type number. PD controller will not change the type number. Okay, now I'm going to find Kp. Kp equal to limit s tends to 0, g of s, h of s. This is the g of s, h of s. If you put s equal to 0, something divided by 0, s will become infinity. Then ESS equal to 0. Previous one also ESS 0. Wait. I want this one. This is the error. I want to decrease this error by using PI controller. Next, KV. KV equal to limit s tends to 0, s into g of s, h of s. 1s will get cancelled. If you replace s equal to 0, it is infinity. Now, ESS equal to A by KV. So A means constant. How much I got? KV as infinity. Something by infinity is 0. Yes, check it out. KV without controller, KV value is 2 zeta A by omega n. Otherwise, if you're not understanding this one, let me write. Not understanding that one. So limit, otherwise you can write it here. That KV limit S tends to 0, S into G of S H of S. S KP plus KI omega n square divided by S square. S plus 2 zeta omega n. One S will get cancelled. There is one more S. If replace S equal to 0, something divided by 0 infinity. Yes, I got infinity. Check it out, error becomes 0. Previous error is of constant. Some error is there. Some gap is there between input and output. If you use PI controller, that error becomes 0. Yes or no? That is the advantage. If you want to improve the steady state response, then you go with the PI controller. Otherwise, if you want to decrease the steady state error, then you go with the PI controller. We will check the closed loop second order system. Sorry. What will be closed loop second order system? Because if it is a closed loop, order is 2. With the PI controller, what will be the order we will see? It is a PI controller. The order will be for PI controller. This is the last one for PI controller. So closed loop transfer function equal to KP S plus KI into omega n square KPS plus KIS omega n square plus numerator plus denominator S square. Send that S square inside. Send this S square inside. You will get S cube plus 2 zeta omega n S square. If you arrange, anyway, I'm not going to bother about the numerator. If I arrange this one in a proper order, S cube plus 2 zeta omega n S square plus KP omega n square S plus K I omega n square. Yes, check it out. It is a third order. Order become 1. So order become 3. So if order of the system is increasing, system may become unstable. If order of the system is increasing 1 by 1, in general it is a second order. Without controller it is a second order. Without controller it is second order. System is stable. System is stable. System is stable. If order is increased by 1, it becomes third order. Then system may be stable or unstable. Stability of a system is going to affect. Okay, now and check the previous one. It is a last term is a omega n square. If you check this, last term is omega n square. If you check whatever the last term here, it is not omega n square. Ki into omega n square. Yes, frequency also changed. So system may become unstable if you are not designing proper value of Ki. If you are not designing proper value of Ki, system may become unstable. We'll see the theory part. PI controller. Theory part about the PI controller. Yes. Check it out. PI controller. We are going to introduce in forward path. Then this is the open loop transfer function. Type become 2, and a closed loop transfer function. Type order become 3. Then order become 3. Then KP 0. KV. Check it out. For both, error is 0. With the help of PI controller, we can reduce the error. This is the theory part. It increases the order of a system. Yes. Without controller, order is 2. With the controller, order is 3. Yes, it increases the order of a system. Next question, it increases the type number. Yes. Without controller, check it out. Without controller, type number is 1. With the controller, type number is 2. So it will increase the type number. What is it? It increases the type of the system. Next, designing of Ki must be proper to maintain stability of a system. Why? Because the order becomes third order. If you are not maintaining Ki value, we check the denominator term. Yes, S cube, that means characteristic equation is equal to S cube 2 zeta omega n S square Kp omega n square S plus Ki omega n square. If you find RH table, s cube, s square, s power 1, s power 0. S power 0 is ki into omega n square. If you are not designing ki value in a proper manner, the system may leads to unstable. That means the relative stability of a system is decreasing. Design of ki must be proper to maintain stability of a system. So it makes the system relatively less stable compared to second order system. If you use PI controller, then the system becomes relatively less stable compared to second order system. Next one, steady state error is eliminated. Yes, I got 0. That gap is 0. Input output is on one line. So steady state error is eliminated by using PI controller. Next, overall, it improves the steady state part of a system. It will improve the steady state part of a system. That's all. This is the PI controller, PD controller. In the next class, that means tomorrow class, I will start with PID. I will go through this comparison chart. Then we will start the PID controller. PI means PD plus PI. This is these two is PD. These two is PI. It is a PI. It is a PD. If you want to improve both the transient response, steady state response, you can connect like this. Then overall time response is going to increase. If you want to improve the overall time response, then go for PID controller. Anyway, in GATE exam, they won't ask any questions till now. They asked the one question from PID, that too comparing with the operation amplifier, op-amp. They combined operation amplifier with the PID controller. One time they ask in control system. The remaining all are theory part only. Maximum IS they will ask theory part. PD controller, PI controller, and the PID controller operation will be same as lead compensator, lag compensator, lead lag compensator. This is the important for GATE exam. Lead lag compensator. Many questions they asked. Maximum weight is 2 marks. Both will be same operation. Whatever the theory part I given PD, same theory part is applicable for lead compensator. Whatever the theory part I given, same thing is applicable for lag compensator. Whatever the theory part tomorrow I am going to give, that is applicable for lead lag compensator. This is the PI controller, PD controller now. Thank you. Let me check the attendance. 1 second.